Welcome to this series. In the next several videos, we introduce computer systems, system concepts, and IT system architecture. In this video, we discuss computers and systems. Please take a moment to read the learning objectives for this video. We live in an area of ubiquitous computing, meaning that it is everywhere. People all over are using their smartphones for entertainment, communication, gaining information, or conducting business. Your smartphone is faster than the most powerful supercomputer in the early 90s. Computing is not limited to how we choose to use it. Computing is widespread with embedded computers in household appliances and automobiles. Our TVs are no longer basic devices that display a broadcast signal, but they communicate through the internet and process data. We can cast a movie or picture from our smartphones to the TV. This change of embedded computing means we no longer have to understand how the technology works to use it. Instead, we just use technology without thought or realizing it is there. Why then does the average person need to study computer system architecture? First, studying it allows you to understand the capabilities, strengths, and limitations of a system. This understanding allows you to use technology differently and to leverage its strength. Next, knowing how something works will enable you to make better informed decisions. Additionally, having knowledge of the topic allows you to improve your communication with the IT professionals. Let's take a look at an example of an IT system and its architecture. This particular model examines using the web browser to get the data from a web page, which uses the client-server architecture. Take note of the inputs and outputs. For a user to access a web page, they first click the mouse on a URL or type in the address. Then browser accepts the input and sends it through the internet using HTTP. The web server receives the request and internally processes it. The web server then sends the data back as HTML using HTTP. The web browser receives the HTML file and displays it to the user. Returning to the previous question of why study system architecture, you can see how understanding the process might improve your knowledge of the need for web security. For example, could someone intercept the HTTP request to direct it to a different location, or even change the content of the HTML file? Now, this model is known as the input-process-output model. This model is composed of 4 components or actions, which are input, process, output, and storage mechanisms. Firstly, a system needs information or command. Examples of input devices are keyboards and microphones. Once the system has inputted data, the system needs to interpret and process the data. The CPU is the component that processes the data. During or after processing the data, the system needs to put the data in either short-term or long-term storage. Data storage devices include USB drives and hard drives. Finally, the system sends the processed data as output. A speaker, monitor, or printer can output the data in different ways. We saw in the previous example that every device or component receives an input, processes it, and sends it as output. This rule is valid even with the mouse. It receives the click action and then sends that information to the computer for processing. A computer is a self-contained system composed of hardware, software, and data. It has a means of communicating. These components also form layers, with hardware being on the bottom and communication on the top. The hardware processes the data received from an input device and sends it as output. The software instructs the hardware what to do and how to process the received data. The software then sends meaningful or interpreted data to a different system, which is communication. Hardware components are the physical components containing the electronics. The major categories are input and output devices, storage devices, a CPU, and memory. A computer system usually includes multiple forms of input, output, and storage devices. A keyboard, mouse, and video camera are input devices. Output devices are speaker, monitor, and printer. Storage devices are hard drives or USB drives. The network and USB interfaces also provide input and output to different systems. The CPU controls all of the connected devices and stores instructions for processing the data in the memory. The CPU is the central computing chip that handles the processing of the various components in the computer. It has an arithmetic or logical unit that performs calculations. The control unit controls the processing of instructions and moves the data within the CPU. The interface unit moves the data between the other hardware components. The CPU is a processor and communicator. It receives, processes, and outputs the data to the correct component. For example, the CPU knows how to interpret the mouse click and perform some action based on software instructions. The action might be to get data from the hard drive, format it correctly, and send it to the printer. The memory component stores the current operating instructions in the data for applications. The instructions from the software are sent to RAM or working storage so the CPU can process those instructions. RAM holds the data that the CPU is currently processing. For example, editing a picture. If the picture is 5 megabytes in size, the CPU puts the data in RAM so it can manipulate the image. We usually talk about memory in the number of gigabytes. For example, my computer has 16 gigabytes of memory. The more memory a computer has, the less frequently the CPU has to write the temporary data to a permanent storage component, such as the hard drive. RAM is very fast, but hard drives are slow. The next component of a computer system is software. The software element has two primary categories, which are applications and operating systems. Windows and Android are operating systems. Chrome and WhatsApp are applications. An operating system provides the interpretations and instructions that allow the user to communicate with the various hardware components. For example, when the user clicks the mouse, the computer has to interpret that command and perform a particular action that results in an expected output. There are many software layers on a computer. Each layer gets closer to talking directly to the hardware. The layers talk to each other through an IP, or application program interface. The API provides the instructions on how to communicate to that layer. The final component is communication, which is sending and receiving data with another computer system. The hardware components include communication channels and interface devices. These channels could be wire cables, fiber optics, or radio waves. An interface device connects the communication channel to its internal components. For example, one might convert radio signals to a format understood by the computer. The software component handles the data connections and manages the data transfer. The software ensures data maintains its integrity and gets to the proper destination. To provide a summary of a computer system, it must have at least one CPU, memory to hold programs and their data, input-output devices, and long-term storage. Computers come in all shapes, sizes, and functions. Smartphones and embedded computers are examples of systems. Smartphones also become part of the larger mobile communication system. An embedded computer has a dedicated function in the context of a larger system. It receives data, processes it, and then sends it as an output. Up this point, we've talked about the physical components of a computer system. Using software allows running many virtualized systems on a single machine. Virtualization is the creating a virtual or software-based computer system inside of another system that operates like a real system. The virtualized system uses the physical hardware of the actual system. Virtualization includes individual components or could include a complete system such as an operating system or virtualized network. For example, a network engineer could create multiple virtual networks using the same hardware instead of installing new equipment for each network. One network could be for the faculty and the other for the students. However, the hardware remains the same. Perhaps you've heard the term VPN or Virtual Private Network. A VPN allows a user to join a network from a distance. If someone does not have a direct connection to their work or school network, a VPN connection allows them to join the network as if they were sitting at the desk connected to a LAN cable or Wi-Fi access point. Another example is a physical keyboard and the software keyboard. Both are input devices that provide instructions to the computer. One receives the input from physical buttons and the other receives input from the touchscreen. Standards are important part of computer systems. They ensure that our systems work universally. For example, standards define what makes an MP3 audio file so that the media player can correctly play the file. Another example is the QWERTY keyboard layout. A user typing on a QWERTY keyboard knows where the keys will be. Protocols are standards that define communication rules between devices, both internally in the computer and externally to other systems. For example, the CPU has to know the rules for communicating with the storage device. When you access the internet, you will be likely use the TCP or UDP protocol. TCP stands for Transmission Control Protocol. TCP ensures that the data gets between point A and point B without getting lost. Examples of TCP are email or web data. However, UDP does not care if the data gets lost along the way. Examples of UDP are video or audio streaming. In summary, the input-process-output model is the fundamental design of computer system architecture. The model is composed of 4 components or actions, which are input, process, output, and storage mechanisms. From a computer system perspective, a computer is a self-contained system composed of hardware, software, and data that communicates. It must have at least one CPU, memory to hold programs and their data, input-output devices, and long-term storage. A computer system can host a virtualized system, which is creating a virtual or software-based computer system inside of another system that operates like the real system. The virtualized system uses the physical hardware of the actual system. An example of virtual hardware is a software keyboard. Lastly, we looked at protocols, which are standards that define communication rules between devices, both internally in the computer and externally to the other systems.